Next, part C says the shortest distance from the curve xy equals 8 to the origin. So we got to be able to first graph our picture. Y is going to be 8 over x, which is a hyperbola sideways. Got a vertical asymptote at x equals 0, and I want to pick a point on the curve and get it close to the origin. So the distance between those two will be the square root of y minus y squared plus x minus x squared. My domain, it looks like x can be anything, positive or negative, but we'll just look on the positive side because any distance we get here is going to be the same as the distance on the other side, and we're just trying to find that shortest distance. So this one I'm going to use my calculator to help me. So I'm going to go into my y equals, and I'll put that distance formula in. So second square root of an 8 over x minus 0 squared plus an x minus 0 squared. And then I'll close off my square root, double check that it looks the way it's supposed to. It does, and now I'm going to turn that off. And I'm actually going to go to my home screen on this one instead of waiting for that derivative, because I don't see that I'll get a maximum distance, so any critical value will be the location of the minimum. So I'm going to solve for when that derivative, which I stored in y2, equals 0 with respect to x. I got a negative value and a positive value. So like we anticipated, we are getting a minimum distance over on the left, or below on the left side, and we'll get a minimum distance on the right. So we'll just look at the distance when x is a positive 2 root 2. So I can figure out what that is by just doing y1 of that 2 root 2, because remember I stored the distance in my y1 equation, and I get a distance of 4. So the minimum distance that I can get from that curve to the origin is 4.